So now that we understand how the angles of elevation and depression work, let's use those in a problem. So for part A, it says for a reverse bungee ride. So reverse bungee, here's a picture of that. You can see you've got someone standing on the ground. They have these bungee cords connecting to the top of these two vertical poles. What happens is they kind of get pulled down here, and then they will get released and they'll go flying up into the air. So that's a reverse bungee ride. Reagan stands halfway between two vertical posts. Some of this is not as clear in your picture. In your note packet, you guys have kind of a black and white version of this. So we can see the two posts are 8 meters apart. Two bungee cords extend from the top of the post to Reagan's waist. So here they are coming down to Reagan's waist. And that is 1 meter above the ground. How tall are the vertical posts? So if we look at the picture, we can see they have identified X as being from the top of the post to this horizontal line right here. Well, that is forming a right triangle. So I'm just going to redraw that right triangle and see what we can solve from this. So here's X. Now, sometimes we don't even realize what we're using. So the horizontal line right here to this line that's heading up above, this is an angle of elevation. So we have a 70-degree angle of elevation right there. And then, do we know any other measurements? Well, Reagan is standing halfway between the two posts, which are 8 feet apart. So if we cut that in half, here's that bottom corner of my triangle. We know that this bottom segment or bottom leg is 4 meters long. All right, so we have a right triangle. We would like to find this length. I can't use Pythagorean theorem because I don't have two sides of a right triangle. It's not one of our special ones. It's not a 30, 60, 90, or a 45, 45, 90. So we can use trigonometry to solve for any missing information. We're going to label our triangle in reference to the 70 degrees. So this X over here is the side opposite. Our 4 meters is the adjacent side. And then we ask ourselves, which trig function uses the opposite and the adjacent sides? So we think through SOHCAHTOA. It's the easiest way I know to remember those trig ratios. And we are going to use the tangent function. So it's always tangent of an angle. Our angle is 70 degrees. That's going to be equal to the opposite side, which is x, over the adjacent side, which is 4. And we solve our equation for x. So in solving, we've been just putting this over 1, so we have a proportion, a fraction equal to a fraction. We can cross multiply. X times 1 is x. Tangent of 70 degrees times 4, we'll just write that as 4 times tangent of 70 degrees. And then that's now a calculator problem. We just type that into our calculator. 4 times tangent of 70 degrees is 10.9899. And it even continues beyond that. So we'll just say that that's about 11 meters. We can feel good about rounding that to 11. So we just figured out that from here to here is 11 meters. The question was, how tall are the vertical posts? Well, this does not get us to the ground. We still have a meter further, or an extra meter on our pole, or our, what is this, a post, to find the total height of this. So the vertical post, we'll say the height of the vertical posts, we know it's 11 meters, and we're just going to add in that extra 1 meter to get it all the way down to the ground. So a total of 12 meters tall. That's how tall the vertical posts are. All right, so part B, switching gears here, we are just going to try to apply these angles of elevation and depression again. How do we use them? How do they come up in examples? So Nadim sees the tour bus from the top of the tower. So here's Nadim up here. tour bus is down here, and here's that line of sight, seeing that tour bus below. To the nearest foot, how far is the bus from the base of the tower? So here's the bus, here's the base of the tower. They want to know what this distance is. So that's where I'm going to go ahead and put an X. We do want to identify a right triangle so that we can use right triangle trigonometry. So we've got a hypotenuse, I'm assuming looks like a short leg, and a long leg. There's our right triangle. We know that this side of our triangle is 180 feet. Now, the thing that we just need to understand is we don't have an angle inside of our triangle right now. We can use the fact that we know this horizontal line. So, by the way, this is an angle of depression. Horizontal line, line below it forms an angle of depression. So this horizontal is parallel to this horizontal. So this 23 degrees and this angle down here are alternate interior angles. So that gives us 23 degrees down here. And now we have an angle inside of our triangle. All right, what sides do we know of our triangle? We know the opposite side is 180 feet and the adjacent side is x. What trig function uses the opposite and the adjacent? That's our tan function again. We really like that one, seems to be very common. So we're going to do tangent of our angle 23 degrees is equal to the opposite side, 180, over the adjacent side, x. So this one looks a little bit different than the one we did above. What we need, our x, is in the denominator of our fraction. Well, that doesn't really change our process for solving. We still can cross multiply. When we cross multiply tangent of 23 times x, I'm going to put the x out front. So x times a tangent of 23 is equal to, let's multiply the other cross product, we get 180. And then we have to solve for x. Well, x is being multiplied by a tangent of 23. Remember, that's a trig value. You know, that's a number we'll get by typing into our calculator. But when we leave it as tangent of 23, if you were to type that in, you'd get a decimal answer and you would have to round it. And then you're using a rounded answer within your work, so your answer won't be as exact. So we like to keep this tangent of 23 in our equation as long as we can. All right, so x is equal to 180 divided by tangent of 23. So that's what we type in our calculator. We get 424.05. And then if we try to figure out what kind of rounding should we do, we just glance back and they did tell us to round to the nearest foot. So that's going to round down to 424 feet. So we just figured out how far away the bus is from the base of the tower.